And welcome back to the studio here. Methane as a chemical feedstock rather than fuel. That's the topic of the next 7-minute conversation. I'm going to have that conversation with Morteza Hadian. Morteza, yeah, we know you. You are already world famous here because we saw you, of course, in the video from Eindhoven University of Technology. You're a PhD candidate over there, and you're doing research on small molecule activation. And joining us on the other part here is Sander van Bavel. Sander, you work at Shell, an innovation manager at ArcBBC. Sander, let's start with you. Why is this work, as we also saw just in the video, why is it so important?
It is so important because, well, we talked already a lot about climate change. Society has an enormous challenge to battle the climate change. For that, we need to reduce the CO2 emissions. We need to change from fossil energy, burning coal, oil, gas, with the CO2 associated, to a more renewable energy, solar and wind energy.
Yeah.
For that, we also need to produce hydrogen from that electricity. We cannot only use electricity, we also need hydrogen. And to do that, there are different options to do so. What we are proposing to do here is to make it from methane, because it has the potential to be more energy efficient, so we can get more hydrogen from the same amount of electricity, but we want to do it, of course, without producing CO2. And that's what we're going to do in this particular project.
And that's why you really have green hydrogen, and you use that to balance the energy grid for at moments when there's no wind and the sun doesn't shine.
For instance.
Well, then I'm really curious about how this research works, Morteza. It's about getting the clean hydrogen, and from then.
Yeah, well, it's not easy. We have to face this problem from different aspects, and we should also take different steps in this way. My colleagues are working actually to make the catalyst optimized or make better catalyst, and also actually looking into the phenomena that is happening and the important parameters that are actually affecting this process. And I'm actually looking to how we can put all these things into action.
Yeah.
And I'm doing experiments, finding if it's actually is something that we can invest on it and push it forward, and also doing computer simulations, models to make the outlook of the process and probably for the future of industry.
I can imagine that you require a lot of computing power to calculate those models because, well, those are not made in simple Excel files, I guess.
Indeed, yeah.
So you have all the equipment over there at the lab.
Yes, yeah, some simulations, if we want to model a fluidized a reactor in real scale, they can take months actually.
Wow.
Yeah.
And Sander, what will eventually be the benefit for consumers, for society?
So, sort of coming back to the start, what the benefit is going to be is that we have a part of the solution for having battling the global temperature rise and by being more CO2 neutral in our energy carriers, while at the same time keeping, let's say, the standard of living we have today. Right? We need to have this energy if you want to keep the standard of living today. We need to have the chemicals that we have today.
Yeah.
This is a way to keep them without having the associated CO2.
So this will be an enabler to a more sustainable and a more greener future, and it will enable eventually consumers to to no more use of, for example, in the Netherlands, gas to heat their homes, but use energy with heat pumps.
Absolutely.
Okay, well that's really great.
Absolutely. And the nice thing of this process is that we both get the hydrogen we talked about, but what we do here to prevent that CO2 being formed, we actually produce carbon. And the type of carbon we try to produce here, carbon fibers, and Morteza might be able to say a bit more if he likes, is a high quality product. So we might be able to use that carbon fibers also, for instance, to make cars with the same safety, but cheaper, but lighter.
But lighter, and therefore...
Hence, again, if you have an electric vehicle, you can actually go further away than what we can do now.
Wow. Can you elaborate a bit more on it? Because this is really interesting, of course.
Yeah, the carbon is a great potential for many industries. One of them, as Sander mentioned, is to building materials of vehicles, or also can be used in other processes like as a catalyst or even in the semiconductors to making chips and for computers.
So it's a really high-end carbon you can use for all those things you just mentioned. Now let's talk to end this short conversation about your dreams, about why you're doing this, and well, what world you want to leave for the next generation after you.
Simply, I would like that the picture that's under depicted comes to reality, and I would like to be a short and a tiny little piece of this puzzle that actually my efforts and my colleagues' efforts help this process to put one step forward.
Great. And Sander, you're working at Shell, as you mentioned, on better batteries, on lighter cars, and eventually you share the same dream and the same vision.
Absolutely. This is one of the processes we hope to, in the end, really get working.
Yeah.
Absolutely.
It's sometimes difficult, maybe for you, for the both of you, to explain what you're doing, and also to mention that, well, that you need a few more years to make all those things happen, while the demand right now is so big.
Yes. I think for both of us, we understand it takes long, but as somebody also part of society, we want to have this to work tomorrow, right?
Yeah.
So that's always the balance. You want it as fast as possible. We all understand that, but it takes time. It is really tricky. There's a reason why we haven't had it today yet.
Thank you very much. Sander van Bavel and Morteza Hadian.
Thank you very much.
Thanks again.